Welcome students, welcome to part 12 of first chapter, that is some basic concept of chemistry of class 11th. In this video we will discuss about the percentage composition and the empirical formula. So as we discussed earlier that about the various laws of chemical combination, but here we are discussing about the percentage composition. If we take any chemical compound, say about like a glucose, that is C6H12O6, so how much percentage of carbon or how much percentage of hydrogen or how much percentage of oxygen is present in one formula unit of glucose molecule? This is our topic. So according to the percentage composition, it is defined as the percentage of an element or any constituent in a compound is the number of parts by mass of that element or constituent present in 100 mass. 100 mass means 100 parts by mass means what? It is called as what? That's why you call it percentage by mass. That means what? The mass percentage of any element present in any compound is equals to the mass of that particular element divided by the molar mass of the whole compound multiplied by 100. That becomes as the mass percentage of a particular element. It tells us about by how much percent it is present in any compound. This is what the percentage composition. If we know the percentage composition, then we can easily find out that how much is the amount present in a particular formula. So next topic is the empirical formula. So empirical formula and the next one is what? The molecular formula. These two are the different forms. But empirical formula is the simplest term or simplest denotation of any chemical compound. For example, if we are taking the glucose molecule, that is C6H12O6. So here the empirical formula is may be written as, that is CHO, where the ratio is 1:2:1. So this is the empirical formula for the glucose molecule. And how it can be find out? So we have the various simplest steps to find out the empirical formula. So basically here the definition of empirical formula, the simplest formula of any substance which gives the relative number of atoms of each element present in the molecule of the substance is called the empirical formula. So as I told you, the example of glucose, one more example we have. For example, we have the benzene, that is C6H12. So in this case, we have the two elements, that is carbon and hydrogen. So here the 6 carbon atom and 6 hydrogen atoms are present in one molecule of the benzene. So it can be represented in empirical form, that is what? CH only, right? So this is the empirical formula for benzene. Now if you just find out the molar mass of this empirical formula of benzene, it is taken as the 12U of the carbon plus 1U of the hydrogen. So we can say 13 gram per mole is the formula mass of benzene ring. Means by finding out the molar mass of each element, or by adding all the masses, we can get the formula mass of the any chemical formula. So here the molecular formula means what? If we divide the formula mass by the number by which it is multiplied. So here we take it what? The number is 6 because the carbon is also 6 and hydrogen also 6. So if you just multiply 13 to 6, we will get as the molar mass of the complete benzene ring. This is what? The molecular formula. So the formula is, molecular formula is equals to N, which is what? A factor by which each element is present in the simplest ratio into the empirical formula. So it is known as the molecular formula. So here we have the various steps, or we have the step-wise manner calculation which is helpful for finding out the empirical formula. Now here the very first point is, if we are having the percentage of each element present in our compound given as, so convert the mass percent, the percentage which is given to us according to the question or according to the data. So the mass percent can be converted to grams. So we are taking the percentage to the grams because it is already known that the mass percentage is what? The number of elements or compounds present by 100 parts of that particular mass. So if we have the mass percentage, we need to convert it into grams, the very first point. And if we know the grams, so we can easily convert it into the number of moles by dividing the number of grams means mass divided by the molar mass of that particular element, right? So if we just find out the number of moles, so now if we suppose we have two or more than two elements are present and we are finding the number of moles to each element, then if you are getting a some number, for example, if I am taking this one, this carbon, hydrogen and oxygen, suppose for this one the number of moles is getting as 1, for this one is getting as 2, for this one is getting as 3. I am just taking only example. So these are the number of moles for carbon, hydrogen and oxygen. So in these terms we have the very smallest number, whole number is 1. So in this case divide the number of moles, each number of moles 1, 2, 1 by the smallest mole numbers or smallest number which we are getting as by dividing into moles. So the number of moles divided by the smallest number we are getting as the complete whole numbers, and after that we need to write the empirical formula by maintaining the numbers after writing the symbols. Means if we are getting certain whole numbers here, then we need to just use these numbers by writing the elemental form, that is what carbon, which is whole reaction number as 1 and carbon is as 2, it is hydrogen which is as 2, and next is oxygen which is as 1. So this is the empirical formula. So we can write it as CH2O. This is the empirical formula for glucose molecule. So this is how we can write the empirical formula. And if we need to find out the molecular formula, so writing the molecular formula by mentioning the N value. So for if I'm taking the example for benzene, so is here the N is 6. So if I'm just writing multiplied by 6, also I'm getting as C6 and acid, which is the molecular formula of benzene. But in case of the glucose molecule, which is what the CH2O, this is the empirical formula by multiplying it by 6, because here also the N is 6 because C6H12O6 is the molecular formula. So if we multiply by 6, we are getting as C6, it is H12 and O6. This is the molecular formula of glucose molecule. So this is how we can find out the empirical formula, and by finding out the empirical formula we can easily find out the molecular formula of any given compound if the mass percentage is given to us. Okay, and molecular formula, as I told you, the molecular formula which represents the true value of any compound. As we discussed here, the empirical formula which represents only the number of elements present in them in a fixed ratio only. It does not tell us about the true value of the compound. But in case of molecular formula, it tells us about the true and exact number of atoms present in the compound. So here the molecular formula, it is a chemical formula which represents the true formula of any compound. So it expresses the exact number of atoms. As I told you, the number of exact atoms present in a compound is denoted by the molecular formula. So here I am just taking as there is N, which is what the factor is equals to molecular formula into entire formula, which is coming out from this relation, which is taken as molecular formula is equals to N into empirical formula, as I told you later. So this is how we can just find out the N, that is what the N factor, by dividing the molecular formula by empirical formula. This is also the relationship between the molecular formula and the empirical formula. So again I just went up with the empirical formula and the molecular formula, because the molecular formula is the exact composition and empirical formula is the simplest composition of any given compound. So that's all from the percentage composition, empirical formula and molecular formula. Thank you. Thanks a lot.